Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to determine whether or not a function is closed. How are we learning it? Through the compositions of functions part 1 notes and the compositions of functions part 1 assignment. When can we use this information? To perform simple calculations such as a budget by recognizing boundaries of numbers to determine if adding the items in your budget will stay within your income amount. How do you know you learned it? By getting a score of 4 on the compositions of functions part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the compositions of functions part 1 notes, and then I'll give you time to complete the compositions of functions part 1 assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to continue working on the reasoning with features of function study guide and any incomplete assignments that you may have. Let's take a look now at the composition of functions part 1 notes. The notes begin with the learning goals and success criteria. So what is an even function and an odd function? An even function is a function that is exactly the same for f of x and f of negative x. So what this really means is that even functions are symmetric across the y-axis. So if I look on each side of the y-axis, I should see a direct reflection or a mirror of the function. So they are reflected across the y-axis. Now an odd function is exactly the same for negative f of x and f of negative x. And what this means is they are symmetric across the origin, meaning that they are rotated 180 degrees about the origin. So what does this really look like? Well, I have an even function here, and if I look at just this side, on this side of the y-axis, if I were to take that and flip it over, it becomes this part here. So every point, if I reflected it across this axis, it would be directly where it needs to be. So this is an even function. Now an odd function is something that's rotated. So I spin it 180 degrees. If I take this point here and spin it 180 degrees, it should end up right there. If I take this point and spin it 180 degrees, it should end up right here, and so on. So the whole function is spun around the origin. So this is an odd function. Now neither functions are just functions that are neither even nor odd. They're not reflected and they're not rotated 180 degrees.
Now let's talk about the definition of infinite set closure. First of all, what does infinite mean? Infinite means an uncountable number of elements. So it goes on to infinity. It keeps going forever. So an example of this would be like the natural numbers. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we can keep counting. And no matter what number we stop at, there's always a number past it. So that's an infinite number of elements. Therefore, an infinite set means that we cannot count the number of elements in the set. The opposite of this would be a finite set in which there are a countable number of elements. So let's say I wanted the natural numbers between 1 and 10. Well, that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and stops, and we can't keep going. So that would be a finite set. So an example of an infinite set would be the set of integers. So there's no limit to the number of integers we can count. Now, closure definition. What does closure mean? Closure under an operation means a set is considered to be closed if when that operation is performed on any two elements within the set, the result is also in the set. Okay, note that this must be true for all elements in the set. If there is even one case where the result falls outside the set, then it is considered to be not closed. Okay, so let's take a look at what this means. So here's an example. We have the set of -1, 0, and 1, and want to know, is it closed under addition? So what that means is I'm going to take each of these elements, so like -1 and 1, and when I add them together, I get 0, which is in the set. So that means that the set might be closed. If for some reason, though, I end up adding two numbers together, and the result is outside the set, so let's say I add something together and I get 6. Well, 6 is not in the set, so therefore it is not closed. So an example of what would make the set closed would be -1 plus 1 equals 0. Because 0 is in the set, it looks like it might be closed. Now, is there an example we can come up with that makes it out of the set? Well, if we add 1 plus 1, because we do need to include it plus itself, so 1 plus 1 equals 2. Well, 2 is not in the set, therefore the set is not closed. And again, if there's even one example of this, so it doesn't matter that this part ended up inside the set. Because this one example is out of the set, then the whole set is not closed. So now let's take a look at this infinite set here, the set S of integers, and what we want to know is it closed under addition. Now we can't use a table anymore, so we need to think of some examples of addition of integers and then try to broaden it and say, is there any way that any two integers can be added together and not be an integer? So we do some examples here, and we can see that they're still turning out to be integers. So is there any way we can add two integers together and not get an integer? So if I add any two negative integers, is there any way to get a fraction out of it? Is there any way to get a real number out of it? Is there any way to get a complex number out of it? Well, no, there's not, right? Anytime I add any two whole numbers together, I should get another whole number. So therefore, there is no way to add two integers together without getting another integer, so therefore the set is closed. Now what about this? The set S of integers closed under division. So again, we're going to think of some examples. So we have 2 divided by 1, 1 divided by 2. Notice here though, when we do 1 divided by 2, we get 1/2. Well, 1/2 is not an integer, that's a rational number. So therefore, when we do it that way, we know that it's not closed. Now, there's an easier way for us to be able to tell that this set is not closed. Because I told you last time, if we include 0 in the set, then it is never closed under division because it's undefined. So if we divide something by 0, it will always be undefined. So 0 is an integer, so if we were to divide a set by 0, it would be undefined. So therefore, that previous set would not be closed because of division by 0. Now, what if we said the set of rationals excluding 0 is closed under division? Well, again, we're going to think of some examples. So we have 1/2 divided by 1/4 is equal to 2, and negative 1/2 divided by 1/3. Remember, really, it's just multiplying by the reciprocal. So is there any way we're going to get something other than a rational number, other than a fraction? Well, we keep thinking of some examples, and when we keep looking, we can see that there is no way, and we did exclude 0, so we know that 0 is not an issue, so we don't have to worry about dividing by 0, so therefore, we can just look at these examples and continue to come up with more examples, and we can see that the set is actually closed because no matter what, when I divide two fractions by each other, I will always get another fraction.
Now there's a video here that shows you how you can use a spreadsheet to find values that you'll need for your assignment for today. So go ahead and watch that video. Let's take a look now at how we can use a spreadsheet to solve math problems. So we're going to use Google Sheets here, and this is for the compositions of functions part 2 assignment. Notice the formulas are already placed in here, so all you have to do is copy and paste them. So I'm going to go ahead and copy this, and then go down 1 and put equals, and then paste it. Then I hit enter. Notice it placed the answer there, and then asks if I want to autofill. I'm going to go ahead and put the check mark. That autofills these. Now I do it again for this one. So I copy this, equals, and paste it. Hit enter, and then autofill. Do it again. Copy this one, equals, paste it, check mark there, and then the last column here we'll do the same thing, copy, equals, and paste it. It asks if we want to autofill, yes we do, and this will be your answer column here. This will be the column that you're using. So you'll put these values into your Desmos activity from here. Then once you're done with this one, you'll go to the next tab, which is here at the bottom, and do the exact same thing. So you'll copy this, equals, and paste, and then autofill, and you'll do that for each of the columns. Then you'll go on to 2C, do the same thing here, and place those values into your Desmos activity. So this is how you can use a spreadsheet to help you with your math problems.
Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google.
Let's take a look now at the compositions of functions part 1 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click start the activity. The activity begins with the learning goals and success criteria as well. We'll go ahead and click next. And it says, use Desmos to graph the following functions and decide if they are even or odd. So I'm going to go ahead and graph this. So I'm going to click on that link and type in the function y equals 3. And notice it's exactly the same on both sides. It is even because it's mirrored over the y-axis. So I'm going to go back here and type in even. Then I'm going to do this one. And I can just copy and paste it. So I copy this, bring it over here and paste it. Sometimes it forms these little asterisks here. Just delete those. There we go. And we can see that this is definitely not mirrored because we don't have this loop going up here. But if we rotate it, it ends up being directly on top of each other. So this is an odd function. So I type in odd here. And you'll do that for each of these. And then we'll click next. Same thing here. Do that for these functions. Now, it says decide if the following statements are true or false. If it is false, give a counterexample. It says the product of two even numbers is an even number. So if I multiply two even numbers together, do I get another even number? Well, 2 times 4 is 8. So yes, I will always end up with an even number. That is true. Now, if it was false, I would put a counterexample right here. So you'll do that for each of these. And then we'll click next. And there's a few more questions. So you'll just, again, answer true or false. And then if it's false, put a counterexample. Once you're done with that, you'll go back to your Google form and click next. This will take you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.